Alright, these are Unit 11 notes for chemistry, Part 4, regarding solution formation and solubility curves. There are three factors that affect the rate of solution. The first would be agitation, which brings fresh solvent into contact with solute. So really agitation is just stirring or shaking. It doesn't affect the amount that will dissolve, it just affects the rate at which it will dissolve. Number two is the temperature. Because temperature is really just the measurement of how fast the molecules are moving, if the molecules are moving more often, it'll increase the rate at which it will dissolve because it will collide more often with the solute particles. So the solution particles will collide more often with the solute particles, which will dissolve it faster. And the third one will be the particle size. The smaller the particles dissolve, the faster because they have a greater surface area, which is in contact with the solvent. Now we have these things called solubility curves, and solubility is just a measure of the amount of solute that will dissolve in a given amount of solvent. We typically on these graphs are going to use grams of solute in 100 grams of solvent. Most of ours will be grams of water. We will have, like I said, solubility charts like this on our classwork. We have them on our homework. And you'll have one on your test. So you should be able to read the table by finding the temperature of your solution or the concentration of your solution, and then tracing over to the chemical compound that we're talking about, and then trace to the other axis to find the corresponding value. So if I was talking about 50 degrees Celsius and I was talking about NH4Cl, then that would be that 50 grams of NaCl would dissolve in 100 grams of H2O. Now that would tell me how much the solubility value at that temperature. Now if I have anything less, then that's going to be considered something called unsaturated, because I could dissolve more. If I have more dissolved than should sit at that temperature, then that's going to be considered to be supersaturated. If I have just that amount and no more will dissolve, then that'll be considered saturated. Okay. So again, like I said, types of solutions. So we have a saturated solution, which contains the maximum amount of solute that will dissolve in a given amount of solvent at a given temperature. So that would be something on the line. We have an unsaturated solution, which would mean that more solute could be dissolved. So it indicates that there's no solid present. Okay. This would be something underneath the line. Now, lots of times with a saturated solution, there will be some sitting at the bottom because you've added so much that it won't dissolve anymore. So there'll just be some solid sitting at the bottom still. It doesn't matter how much you stir it or any of that, it'll still just not dissolve. Okay. And then we have what's called a supersaturated solution, and this is where more solute is dissolved than should theoretically be there at that given temperature. So that's something that's above the line on the solubility graphs. Okay. Now when you have a supersaturated solution, this is what a supersaturated solution looks like if it's cooled down properly. And so it's holding more than it's supposed to. But if you add a seed crystal to it, it'll actually cause all of it to come out of solution and it'll solidify. It's kind of pretty cool. Okay. So again, you can have an unsaturated solution. It's not dissolved. Okay. All of that will continue to dissolve. We can keep dissolving it. Now it's saturated. There's just a little bit there still. So if we add some heat, we'll make it where all of it can dissolve. So that's now unsaturated though at this new temperature. And so then if we slowly cool it, there's no precipitate yet. So we would say that that's supersaturated. But once the precipitate starts to come out of it, then we're calling it saturated again. Okay. So we talk about miscible versus immiscible. Miscible is really liquids that will dissolve in each other. Ethanol and water do dissolve in each other. where immiscible is just liquids that aren't soluble or won't dissolve with each other, like oil and water. So it's just other vocabulary words for you. Now, most solids become more soluble at higher temperatures. There's a few, like N2, Na2SO4, and Ce2SO43, which is sodium sulfate and cesium sulfate. They actually become less soluble at higher temperatures, but most of them, as the temperature increases, so does the solubility. So what mass of NaNO3 can be dissolved in 100 grams of water at, I think it's 100, oh no, this is 250 grams of water at 20 degrees Celsius. So what we're going to do is we're going to go to 20 degrees Celsius, and we're going to go to the line, and we're going to go over. So roughly, we're going to say 90 grams roughly can dissolve in at 20 degrees Celsius of NaNO3. Now, so if we read it, that's 90 in 100 grams of water, but we want to know about 250 grams of water. So 90 over 100 would equal how much over 250. So we could just do the butterfly effect, cross multiply and divide. And so we take 90 times 250 divided by 100, which would then give us 225 grams. Now when we're talking about gases though, gases are always less soluble at higher temperatures, but they're actually more soluble under pressure. So, but when we're looking at them just on temperature solubility graphs, they always decrease. And that's why when your sodas get hot, they bubble more, because the gases won't stay dissolved in the solution as the temperature increases. Okay? So that concludes part 4 of our Unit 11 notes.